Good morning, everybody. Welcome to another Construx Lunch and Learn event. Today we're going to talk about successful sprints and how to get them by getting things done. My name is John Clifford, and I am what we would call a senior fellow at Construx and the Agile Practices Lead. And I have been in this industry for the last 35 or actually 40 years. Don't tell anybody, I think I'm getting old. And let me share with you some of the things that I've learned. So first I want to talk about our Lunch and Learn program. We started a similar program in 2009 during the after effects of the Great Recession, as it was called at the time, just to help software engineers work on their skills and practices during some downtime. We've continued that process in 2020 here to help the community out, especially to help people working from home and work with the problems that you may be facing from working from home. And certainly if you're running a Scrum team and you haven't worked remotely or distributed fashion, you have found some challenges. We're going to keep this program up until at least the end of April, and we encourage you to share it with your friends. So thanks for joining me. You can use the chat window in Teams to type in your questions. We have a moderator who will look at the questions, and if anything is technical, it will be handled by Jesse, who is our producer in the background. Otherwise, it will be brought to my attention and we'll handle it. I will tend to defer most questions until the end unless something seems extremely pertinent, and in which case another person working for us, Eric Simmons, will prompt me from the background to remind me to clarify something. We'll go from there. Please avoid hitting the space. It'll pause the presentation for you. Okay, so let's talk about our agenda for today. I want to talk about what a successful sprint is and why they matter. This may seem obvious, but I get paid to state the obvious, so bear with me. We'll talk about some of the challenges we encounter with successful sprints. Well, then we'll talk about what does done mean. You've all heard the expression done or getting to done. And we'll talk about what that means in the context of Scrum and software development and when and where to use it and how to use it. Then we'll talk about starting the journey to successful sprints using done at all parts of the development lifecycle. And finally, we'll end the presentation and the seminar with a call to action and a Q&A session. So let's talk about what is a successful sprint and why successful sprints matter. So how many of you have heard a book called Chasing the Rabbit? It was one of the books written in the mid-'80s about the Toyota production system, or what we now know as Lean. And the term rabbit came from the concept of a market leader. So studies have shown that the majority of people who buy a product in a market buy from their first choice, and that choice is the market leader. They tend to have either plurality or the majority of the sales in the market, and they greatly influence and drive the market. Most of the rest of the consumers who don't buy from that first choice will buy from the first alternate choice. And that first alternate choice is what we call a key competitor or a market challenger. And then if you're number 3 or number 4 on this list for competitors, you typically get single-digit market share. One good example from today's phone business. So we had the iPhone, which used to be the market leader, and now it is probably what we would call the primary alternative choice, because Android and as the operating system of choice and Samsung as a vendor is the market leader in the mobile phone business. And then we have Apple with the iPhone, and then everybody else fights over what's left. So you get to be the market leader when you can deliver best what customers want, and you can deliver as quickly as the market wants it, or at least more quickly than your competitors can. So that most agile competitor is what we call the rabbit. And here's the deal, either you're the rabbit or you're chasing the rabbit. And the problem with chasing the rabbit is by the time you get to where the rabbit is no longer there. They're ahead of you, okay? So you're falling further behind. So somebody in your market is going to be the rabbit, the market leader. Why not you? So let's talk about some of the problems we face and why, again, successful sprints matter. Demand for work always exceeds capacity. Work is infinite, time isn't, right? The world always wants more than we can give, but we only can do what we can do in the time allotted with quality. So therefore, we must do the most important thing in the shortest reasonable time while simultaneously looking to improve our ability or our capability to deliver work. And this is right from the Agile Manifesto, right? Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. So let's talk about Agile, okay? What does it mean to be Agile? Agility is simply defined as the ability to respond effectively to change. If you think about the opposite of agility, it's chaos, right? The inability to respond effectively, or only the ability to respond ineffectively to change. So agility is not a state of being, it is a continuum. It's a value on a scale or a spectrum, right? You can be more or less agile. Now, the more agility you have, the more you're able to respond effectively to change, the faster and more appropriately you can respond to market changes. Okay. So let's not confuse agility with agile in terms of how it's used in industry, and Scrum with agile. Agile is not Scrum. Okay, agile is that mindset that gives us the ability to respond effectively to change. Scrum is an agile framework when done properly. If you don't do Scrum correctly, if you do it badly, you won't be agile. Okay, agility doesn't just apply to software development; it applies beyond software development to all aspects of the business. Okay, to any business. Any organization can develop its ability to respond effectively to change. They do that by harnessing agile principles at any level, and that helps those organizations be more effective and efficient in the market. So you don't have to do Scrum in order to become more agile. However, having said that, if you're running projects, Scrum is a fantastic framework for increasing your agility, for being more efficient and more effective. Now let's talk about successful sprints and why they're important. They lead to successful releases. Successful releases lead to successful products in the market and help you become the market leader, the rabbit. So to be successful in the market, you got to do two things. You have to do the right thing, and you have to do the thing right. You have to deliver a uniquely different and perceptibly better solution to the customer's problem that fulfills their needs and provides the benefits they're looking for. Now, doing the thing right is all about execution. You have to deliver the product quickly and with high quality so the product does what it's supposed to do. It's got to be robust and reliable and performant, right? Now, of those two things, most companies that are successful are capable of doing the right thing. However, they may not be capable of doing the thing right, of executing as well as they could. So what is a successful sprint? Let's talk about a useful definition. A successful sprint is when a Scrum team establishes a sprint goal and achieves it, right? That is success. Now, if we don't achieve the sprint goal, have we failed? If we've learned something so that we can be successful next time, I would say no. But if we keep on bouncing off failure and we're not learning, then we're certainly not being successful. So successful Scrum teams set reasonable, achievable sprint goals and generally accomplish them. Successful Scrum teams also get better and better over time, faster and faster, okay, as they continue to learn and improve. So remember, when we talk about faster and faster, there is no completeness without quality. So successful sprints result from successful execution, right? The PO should be giving us guidance on value, and the team should commit to a reasonable, achievable amount of effort, and then they should achieve it by fully implementing sprint backlog items by the sprint end as a product increment. And remember, the product increment is defined as a combined output of this and previous sprints. So a product increment may need additional value to deploy and release, requiring multiple sprints, but must never knowingly require rework of the output of current or previous sprints. In other words, it's okay to have to add more functionality to create sufficient value to release an increment, but it is not okay to have to go back and fix things before we can release, right? So this means that the team cannot consider items to be done if there are known issues with quality, functionality, appearance, performance, etc. Any rework negates the concept of being done. So are your sprints successful today? I'd like you to write this down so we can talk about it toward the end of the seminar. What does your organization consider to be a successful sprint? Or do you even think of that term? Do you set sprint goals with your Scrum teams to what the teams can reasonably deliver? And remember, when we say you, we're talking at the team level. The Scrum team has to set its goal. It gets guidance from the product owner, right? But the team itself sets a goal if you're running Scrum appropriately. Does the team achieve its sprint goals, right? It's one thing to set a goal, it's something else to accomplish it. So if you're setting a goal, but you're not hitting a goal, the system is telling you something, okay? Are you paying attention to it, right? If you are achieving your goals and you get it done, are you delivering product increments that don't require rework before deployment and release? If not, I would question as to whether or not you're getting it done. And remember again, I'm going to keep on reminding you of this. Done does not mean contain sufficient value to deploy and release to customers. It means is sufficiently complete so that we can add to that, but never have to go back and fix it. So is a successful sprint synonymous with a successful deployment and release? Again, only if that successful sprint ends up with a product increment with sufficient value to justify the cost of deployment, both to your organization and to the customer. Let's talk about some challenges of successful sprints. We commit to more work than we deliver within a sprint. That often happens when we can't achieve our goal. So the question there is, does your team understand how much work it can reasonably complete in a sprint quantitatively? There's another failure mode. We commit to backlog items that we don't understand. Do you have an effective refinement process with exit criteria, what we might call the definition of ready? Okay. Another challenge, we commit to a sprint goal with our sprint backlog, but we lose focus and work on other things instead of working on the goal. Okay. So is all the work your team needs to do only on the sprint backlog? Do managers or other stakeholders come into your team and try to steal resources and assign work to them that is outside of the sprint goal? Remember, Scrum says that all work for a Scrum team must come from the product owner through the backlog, through the sprint backlog. So if external stakeholders, managers, etc., want the team to do additional work or other work, they should be going through the product owner. Okay, if they're not, that is a failure to follow the rules of Scrum. Finally, a serious challenge is that we commit to a sprint goal, but we fail to anticipate rework from defects that prevent us from achieving our goal. So how much of your team's bandwidth, how much time during a sprint does your team actually spend fixing defects from previous sprints? Okay, we have found, to our dismay, that many organizations, in fact, the majority of organizations, spend at least 25% of their sprint bandwidth working on defects from previous sprint. And that is simply explained by the fact that they're not getting to done with the output of previous sprints. So let's talk about workflows for a second. Okay, so what is a workflow? A workflow is a sequence of stages that work progresses through from an initial state to a final state. When we talk about a product development workflow, we're talking from the initial idea, okay, down through planning where we chunk it out into features, and then we go through the end of planning where we take those features and break them down to separate backlog items, what we might call user stories. Okay, and then when we enter the execution phase of our project, we go through a refinement process where we refine those backlog items so that they're understood, they're sized appropriately. Any UI or design issues have been handled outside of the sprint, and we know that we can pull it into a sprint and get it complete. Okay, so each workflow stage in a workflow is transformational. Work enters in an entry state, and work is done to transform it into its final or exit state. Okay, for instance, refinement. The entry state of refinement is we have a backlog item that is not fully understood and may not be sized appropriately. But the exit criteria for refinement is that the backlog item is sized appropriately, is well enough understood, has acceptance criteria, and the team understands and agrees with the product owner's expectations, and also further agrees that if we pull it into a sprint, we can complete it within that same sprint. Now, what we've learned from the lean thinking people is that a perfect workflow stage is one that finds and fixes all defects introduced in that stage before allowing the work item to propagate to downstream stages. So think about that as done. Lean thinking encourages us to have workflow stages that transform work to a done state where they don't require rework, right? Incomplete, flawed work is not allowed to proceed to the next stage. So let's talk about done and what done means and when to use it. Okay. So getting to done, what does that mean? Done is simply shorthand that means the extra criteria for a specific stage in a workflow. For instance, if we talk about refinement, refinement is a stage within the execution phase of a workflow where we look at our backlog items and we prepare them for successful implementation during a sprint. So ready is the done criteria for refinement. If an item is ready to be pulled in the sprint, we say that it meets the definition of ready, and we should have an explicit quantitative definition for that. Again, the definition of done is simply the extra criteria so that backlog items can leave a sprint as done and are ready to go downstream, whether to deployment, the downstream testing, etc. So post-sprint extra criteria, which is not a part of Scrum, but it is a very important part of any software development lifecycle, may include the definition of deployable. When can we take our product increment, and usually at the feature level, either down to downstream post-construction testing or can we deploy to production, whether or not it's enabled for customer use. And finally, there's a definition of releasable. This is function that we've deployed to production, and it meets sufficient criteria so that we can enable it for customer utilization. Most organizations have heard of a definition of done. Has your organization heard, or do you use a definition of ready? And if there is post-development work that has to happen before deployment, do you have explicit definitions for what done looks like at those stages? Should you? So let's understand the definition of ready in detail. Now, I'm going to give you a little background here, because refinement is a ceremony. It's not part of Scrum, but it is a ceremony that was created to handle the problems of and difficulties and challenges of sprint planning. So many teams will go into sprint planning with a prospective sprint backlog as given by the product owners, and yet the team does not have sufficient understanding of those items and what work has to be completed in order to fully implement those to the product owner's satisfaction. And it's hard to cover this for many backlog items in a 4 to 8 hour window. So refinement was an additional ceremony created by many influential leaders in the Scrum world. And the goal of refinement is to ensure that we spend enough time over the prior sprint or two to look at upcoming backlog items to ensure that the major ambiguities or uncertainty have been identified and eliminated. Okay, we don't have to drive out all uncertainty. We have to reduce the uncertainty of a backlog item to the point that we know we can handle that remaining uncertainty readily within the confines of a single sprint. Otherwise, we can't commit to the item to be done in a single sprint. So the definition of ready is simply that criteria by which we evaluate the sufficiency of our understanding of functionality and design of our product backlog item so that we can proceed confidently with implementation. Now, Mike Cohn gave us an initial concept of the definition of ready with his INVEST criteria for evaluating the sufficiency of backlog items. Everybody knows that INVEST stands for, it's like a 6-step checklist for items. For instance, is a backlog item independent? Is the order of implementation independent or not dependent upon other items being done first? That's an ideal. It can't always be met, but ideally, if we can do it, we'd like to have independent backlog items as much as possible. Is the actual implementation of the item negotiable? Does the backlog item contain criteria that describes what the item should do rather than how it should do it? Of course, the backlog item should be valuable. That's the be in INVEST, because if it's not valuable, why are we working on it? Because our goal is to deliver value. Is the item estimable? Is it small or sized appropriately? Those two criteria usually go together, because if we can't estimate it readily, the item probably isn't small or sized appropriately. And by the same token, if it's not small or sized appropriately, our estimation process will be very difficult. So both of those are a check on each other. And the final letter T in INVEST is used for, is the item testable? And we explain that further by saying, do we have quantitative binary test cases? You know, does it do this? Yes or no? Does it do that? Yes or no? That's quantitative binary test criteria. I want to remind you that the INVEST acronym and the checklist that it provides is not a definition of ready. It is a start to the definition of ready. So let me give you some additional steps I would look at to include in a starting place for your own definition of ready. One of the things that you should check for and be able to answer yes or no is that the team has a sufficient understanding of UI and software design to ensure implementation is straightforward with low uncertainty and without needing external assistance during the sprint or during the implementation time. So we know enough to go forward without having to stop and be dependent on somebody outside of the team coming and answering questions or helping us. Okay. Another criteria, the item should be sized, and again, ideally should be sized, the size should be quantified in terms of an estimate of the magnitude of the work, not in terms of duration of work, because duration is dependent upon the people doing the work, whereas the magnitude of the work is independent of that. Okay, and we can talk about estimation in a later seminar or in a later part of this section, but we should size, which means estimate our items, and they should be sized so that the developers on our Scrum team agree that this item can be fully implemented in less than a full sprint by less than all of the developers. Okay. We should have explicit criteria for functional sufficiency. We call that acceptance criteria. Okay, and that it should be defined with a shared understanding and agreement between the developers and the product owner. Right? We want the product owner to say, this is how I want the product to work. We want any questions that need to be asked and answered, so that everybody says, yes, we understand what this means, we understand what we have to do, and we can meet this criteria. And finally, the quick sanity check is no one on the Scrum team, especially the developers, objects to consider this item in the sprint planning meeting. No one thinks it's unreasonable, it's too ambiguous, they don't know enough. Everybody readily agrees that if we decide to commit to this in the sprint, it can be done. Now let's talk about the definition of done, which is that exit criteria so that backlog items can pass successfully through a sprint review and leave the sprint and go downstream in our workflow, right? Okay, so this usually includes compliance with all the functional requirements. In other words, usually your first bullet in this definition of done checklist is meets or complies with all the defined acceptance criteria. Okay, we also cover our practices with the definition of done. We want to make sure that the item has been completed in compliance with all of our process, practices, and standards requirements and policies that are either established by the Scrum team itself or by engineering management that applies across multiple teams in a project or at the organizational level. Okay, the definition of done is agreed to be adhered to by the Scrum team in our working agreements, and this agreement is enforced by the Scrum Master. In short, if I'm the Scrum Master and we're at a sprint review and I know that an item does not meet the definition of done, I will not allow you to present it at the review for approval by the product owner. What might that mean? Let's say we have a requirement that we have unit tests written with a certain percentage of code coverage, and I know that's not done for a particular item. I will tell the team that they cannot present it as done because it is not complete according to our process standards. So here's a sample definition of done. Again, this is not the end-all, do-all. This is a starting place that you should take and adapt to your organization. Let me make another point. Usually items that comprise similar types of work or areas of work have the same definition of done, and we may have extensions for certain things. For instance, if I'm doing a large cloud-based software as a service web application, I may have a core definition of done that applies to all of the work I do. Then I might have front-end specific definition of done criteria, and I may have back-end specific definition of done criteria. The core applies to everything. If this is a front-end piece of work, maybe it's done in Angular or React. I may have one set of additional criteria I want to look at. Again, if it's back-end done in Node, I may have another definition. Okay, so all acceptance criteria must be met. We talked about that being the first bullet of a definition of done. Many other teams will add a requirement that all functionality must be able to be verified through automated testing. So we've written these test scripts, they run, they pass, and they're added to our test suite so that we can run them automatically with builds. Okay, all of our code should be checked in as per our source configuration management rules. How many times have people left out a header file or something and code builds on the developer's desktop, but it doesn't build in the build system and therefore our build is down? Now, thankfully, we have better approaches to source configuration management than we had years ago, and we have better build systems that tend to catch this thing early, but not all organizations or software teams use the latest and greatest tools. Okay, so don't let the tool be an excuse for not doing our jobs. Here's another one. Sufficient unit tests are written to verify all code paths. So many organizations put a code coverage requirement in for unit tests that we must test every branch in the code that we write with at least one unit test. Okay. Non-functional tests are written to verify performance and robustness. Many organizations use performance testing, memory leak testing, etc., to spot non-functional issues. For instance, if there's a standard for the ability to access records in a database, and there's a performance criteria set, we might write a test suite that will verify that, and if the test ever fails, we know it happened because of some work that was done in the last sprint, and we can figure out what that is, and we can rewrite it or optimize it so we no longer have the performance hit. It's better to catch those things when they happen than to try to fix them all at the end of the product. Remember, you cannot paint on quality, you have to bake it in. Code reviews. Most organizations require code reviews, so a good criterion in the definition of done is that code reviews are completed and the adherence to code standards has been verified. Okay. If your organization does not do code reviews, I would ask why not. That is a well agreed upon best practice. Do you have a coding standard? How your code should be written in terms of its layout, the use of variables, etc. If not, there are plenty of them out there. In fact, there are de facto standards for every popular language that you can just get off the internet, and those are good starting places. All code builds without warnings or errors with no test failures. I cannot tell you how many organizations I go into that have a lot of niggling defects, and when they build their code base, they get thousands and thousands of warnings. So when a compiler gives you a warning, it is telling you that it is not sure what you, the developer, are trying to do, so it's going to guess. And here's the problem with compilers. They often guess wrong. Don't make your compiler guess. Don't allow warnings in your builds. Okay. Now, if you have these thousands of errors, you're not going to fix them all in the next sprint. You can adopt a policy, and you might make a slight change to your definition of done by saying all new code or any touched code will build without warnings or errors. So if I go in and change a method in a file, the code within that method should no longer generate warnings or errors. And gradually over time, your code will clean itself up to the point where maybe between releases, you can spend 2 to 4 weeks and make it a goal to pound out all the remaining warnings and errors. What about static code analysis? Many compilers have it built in. Many people use third-party tools. These are great tools to catch silly developer errors, and I encourage your organization to adopt one of these tools and use it. Okay. And again, no known defects. This is, again, in accordance with that lean thinking of ensuring that we do not let defects propagate downstream to the next workflow stage. One thing we've learned in this industry is that if a defect jumps to the next workflow stage, we've just added an order of magnitude to the cost to resolve it. For instance, if I am creating requirements for a product or a release or a feature, and I spot that there's an issue with the requirements while I'm defining those requirements, it's very simple to change a line or two of text, right? Or to update the some information I put in a backlog item in a tool like Jira or Azure DevOps. If we actually go through a design process, I've spent some time doing software UI design, and now I have a low-level wireframe of how the UI should look, and then I decide it's wrong, I've got to redo that wireframe. Let's say we implement the functionality, and then only at the sprint review do we realize this is not what we want. Now I have to go back to the respecification and redesign and layout and reimplementation. And of course, if this issue gets into release and customers see it and are unhappy, it costs a heck of a lot more to fix it. So this is why we don't want to let defects go downstream. It's much cheaper to fix the defects as close to where it happened in the life cycle than to let it go downstream. Okay, even though it seems like it might be a better idea to batch these things up and handle it. We'll talk a little bit later on why that's not a good idea. So this is a good sample definition of done. I encourage you, if you don't have a written definition of done, to look at this and use it as a starting point for yours. Adapt it to fit your environment and your processes. Remember that that principles scale, but practices have to be adapted. And this is a practice that you should adapt to your context. Okay. If you already have a definition of done, see if there's things in this definition of done that you might have left out and might be a good idea to put in your definition of done. So over time, what usually happens is as people spot process issues or deficiencies that let defects get out of sprints, they start adding some criteria to the definition of done to catch those things. Okay. Now, again, we don't want to keep on painting this so we have a 40-page definition of done. We should be able to keep this to, 10 to 12 lines, and it should be good enough. But be willing to clarify or extend some of these lines if you're not getting the results you're looking for. So let's talk about the definition of deployable, if this would apply in your organization. Now, this is often done at the feature level. When you've got enough backlog items that comprise the functionality of a feature that are complete to now support functional testing at that feature level, right? So we may deploy these to a test environment, and that's what definition of deployable may mean, okay? And so now we can test it and do end-to-end user functionality testing. Of course, modern environments, if we're doing software as a service, again, based in the cloud, we can often separate deployment from enablement or release. I can put code into production, but my users don't see it until I enable it at runtime, okay? And that's ideal. Now, many people are using DevOps pipelines that automate the process of going from delivery at the end of a sprint to actually being deployed to production and enabled for customers. And if that's so, your definition of deploy should be baked into your DevOps process, so it happens automatically. If things don't meet the definition of deployable, the DevOps process for that item comes to a halt. Now let's talk about the definition of releasable. Okay, this is whether we actually enable that functionality for users. This is often combined with that definition of deployable when we're building discrete device-based applications or on-prem solutions when the cost of deployment is high. If I have to do a firmware update to a mobile phone, I am probably not going to separate deployment from enabling the use of the functionality. They're going to be combined. If, however, I'm working in a cloud environment or on-prem where I can configure the application at runtime easily and at low cost, then I might separate them, okay? Now, again, releasable, when we enable functionality for customers, is usually a business decision more than a technical decision, or it should be our goal in engineering to make it a business decision. We may as part of an overall larger release goal, start releasing functionality incrementally to our product, but for purposes of the business or marketing, we may not enable them to a certain point, and then one day they get turned on. So this would, of course, require us building some infrastructure into our product to support dynamic enabling of functionality, or disabling of it for that matter. Does your organization have a definition of deployable or a definition of releasable? If not, should you consider these? Could you bake them into your definition of done if you release at the end of a sprint to your customers? Yes. Okay. That works for small teams. If I have a one-team project or maybe a two-team project that works very closely together with good communication, we may find that we can use the definition of done to encapsulate deployable and releasable criteria. But for larger organizations, multiple team projects that may take many sprints to produce sufficient functionality, or in certain industries such as regulated medical devices, we may be forced by the market to accumulate that product increment in a larger batch and separate the cadence of deployment and release from the cadence of delivery by the teams. Okay, this depends upon our environment. Okay, but again, separating the cadence of delivery by the teams from the cadence of deployment and release to the customer is a very powerful technique. Let's talk about starting the journey to successful sprints using done criteria. First, remember that this is all about addressing problems and not symptoms. When we find a problem or an impediment in a workflow stage, we call these undesirable effects, and they are almost always the result of insufficient completeness or doneness in an earlier upstream workflow stage. Here's an example. The team didn't complete the sprint backlog item because of disagreements on the appearance and functionality with the product owner, okay? Or maybe lack of clarity on what this thing should look like or how it should work. It wasn't readily defined. So the undesirable effect is we didn't get our sprint goal accomplished because we couldn't comprehend the desired UI layout and functionality. The root cause is that we really weren't ready to pull this item into our sprint, and we should have considered it during sprint planning before it was ready, okay? So again, we have to make sure we don't treat the symptom, treat the problem. Okay, so a part of being effective in terms of making improvements to our processes is we shouldn't be guessing at solutions. We should be thinking and using the scientific method. Remember that a solution to a problem that doesn't solve the problem isn't a solution. Okay, so again, use the scientific method, plan, do, check, act, the Deming cycle to analyze, diagnose, and solve problems instead of just randomly trying things. How many of you are software developers out there? Have you ever worked with somebody who, when faced with a defect, changed 10 separate parts of code, rebuilt it, and the defect went away? If you don't know why you fixed something, chances are you haven't fixed it, you've only hidden it, okay? You must understand that undesirable effect and then trace it back to its root cause. And then you have to just figure out, what can I do differently to eliminate the undesirable effect? You should describe what success looks like quantitatively. If I make this change, this is what I should see, and I can measure that, okay? And then you should experimentally implement the approach you're thinking of, and then measure it against that success criteria to make sure you've actually identified and fixed the problem. If it doesn't work, it's simply the system telling you that you thought you understood something that you didn't. Back it out and try something else. The debugging process is just like debugging software, okay? Sometimes the problem is what we call complicated. You can think about it, and then you can figure out what you need to do, and you can fix it. But often the problem is what we call complex, which means it cannot be fully understood until you try some things and they inevitably fail. And from that failed experiment, you actually learn to try something else, and you eventually figure out what the real problem is. You have the aha moment. So don't be afraid to try something, okay, that seems like a really good idea, but may not work. Okay, but if it doesn't work, pay attention. The system is telling you that you didn't fully understand it. Try something else. So here's some strategies to use during sprints to address and resolve impediments, right? If I'm during a sprint, we've identified a problem, that's an impediment that's causing us, that's threatening our ability to hit our sprint goal, use a Kaizen circle. This is simply getting the team to meet together either at the end of or right after the daily stand-up to talk about the problem that we're running into and figure out a way to either solve it, or if we can't solve it quickly and assuredly, let's manage it by working around it. So we're going to gather the team, discuss the problem, look for a quick solution, an obvious solution, or if we can't come up with that, figure out a way to get rid of the block so at least we can make progress. Okay, so if we solve a problem, great. If we don't solve it, but we've worked around it, good enough until the end of the sprint. At the end of the sprint, this is where the sprint retrospective comes in. This is where we should actually do a deeper dive into the problem in terms of root cause analysis, understanding, and then devising effective solutions. So again, we're going to gather the team. We're going to discuss this problem not in terms of the issue, like we failed to get this item done. That's undesirable effect. Let's do some root cause analysis. Okay, we failed to get it done because we weren't quite sure what it is we had to do. We weren't quite sure because it wasn't fully understood before at sprint planning. It wasn't fully understood because we didn't go through a full refinement process and reach agreement and consensus on it. So the change here is to look at our refinement process, the process that we go through before the sprint starts, to evaluate and refine and define through progressive elaboration backlog items and their acceptance criteria. We need to work on that. We need to improve it. And then if we're successful, we should no longer be bringing things in the sprint planning meetings and into our sprints that we've committed to that we cannot finish because of lack of certainty. So let's talk about a Kaizen circle, how this might actually happen during a stand-up. Okay, so here we are. We're maybe late toward the end of the sprint, and we're looking to see if we're going to actually hit our sprint goal. And then the Scrum Master points out that we have 3 sprint backlog items that have been waiting for days for a code review before they can be checked in and up integrated. And if we don't get them done quickly, they're not going to be fully tested and finished by the end of the sprint. So we're not going to hit our goal. So the team might meet after this meeting briefly to find out who will take each review. Again, this is a risk mitigation issue. We're gonna step up and dynamically address this issue, but not the conditions that led to it. So we may find that we get 2 of the 3 reviewed, the corrections are made, and then we get 2 of the 3 completed, but we didn't get the 3rd one done. And so therefore we didn't hit our sprint goal. Now, is this good enough? No. We committed to getting these 3 items done, we only got 2. So there was something we didn't know at the beginning of the sprint that we know now. What is it? We've managed this problem for the short term, but because this has likely happened before, it's going to continue to happen. If you keep on doing the same things, you're going to get the same results. So this is what we do during a sprint. Now let's talk about how we might handle this at a retrospective. Okay, let's come up with a solutioneering example. Let's, as I said in what was a movie with where Matt Damon went to Mars and got stuck on the planet because of an explosion. Let's science the crap out of this, right? So we're at the retrospective. And so one of the team members points up, aren't we tired of failing to hit our sprint goal because of untimely reviews? Let's figure out how to fix this once and for all. We're talking about a rules change. So we know that code reviews take 30 minutes, let's say, in our organization, but we have to wait for days. We put a pull request out and it sits there, and it sits there, and it sits there. And often the reviewer looks at us and says, hey, you need to change this, sends it back to us. And we get that information, but we wait for maybe a couple hours to a day because we're working on something else. We get back to it, finish up, we resubmit it, and we still have to wait because it sits there and sits there and sits there. So this might be 30 to 40 minutes worth of work in terms of the actual time it would take to do if we sat and did it. But because we don't, it takes 3 to 4 elapsed days. That's 40% of our sprint. So the team agrees that any pending code review must be addressed within a day. In other words, if I come in the morning and there's a code review, I'm going to do it before I start my regular work. And if I come back from lunch, when I've taken a break from my regular work, and now there's a code review pending, I'm going to complete the code review before I get back to my regular work. Okay. And let's also agree that in order to cut out the latency caused by this delayed feedback, where we're asynchronously communicating, I send you a message, and an hour later you read it, and then 2 hours later you do the work, and then 4 hours later you send me another pull request. Reviews would require that the reviewer and the viewee have to pair. We can do this virtually using a tool like Teams. Okay, or we can do it physically if we're co-located in the same office. One person can go to the other person's desk and we can do the review together. Okay, and what the advantage of that is that quick feedback loops make sure that if the reviewer and the submitter disagree, we can hammer the problem out right then and there. And now reviews take 45 minutes or less. We don't have to wait. They're done within 8 business hours when they're submitted, usually within 4 hours. Okay, they're once and done because there's no back and forth because we're sitting together. And now we no longer have this review latency problem. How can we tell if this worked? We should never see an item sit there for more than a day to get a review done. And we should never have items that don't get completed just because the review took too long. So let's talk about the root cause of most of our impediments, right? Lack of a shared understanding of what should be done. Your team is following a workflow, whether that workflow is formally defined or not, okay? If it's not formally defined, then it's basically what we call tribal art. People talk generally about how the work should progress across the software development life cycle, and everybody has their own mental map in their head of what that looks like, but often those mental maps are very different across the team. Now, shouldn't all aspects of your workflow be explicit? Shouldn't you have an explicit model of your workflow, how work flows, what happens within a workflow stage, what criteria must be met to bring it into that stage, what criteria must be met to make sure it's completed at that stage and can go downstream? Okay. Are you able to measure flow of items across your workflow and within your workflow? Do I know how many items I have in my sprint? Do I know how long they've been there? Do I know how long things have been sitting queued up, ready to be pulled into a sprint? Would that be helpful information to know? Right? Do you have explicit definitions in your organization of what it means for a backlog item, a story, to be ready to pull in a sprint? Do you have that definition of ready? Do you have an explicit written definition of done? Okay, that's not just about functional completeness, but also about process and standards completeness. Okay, do you have a definition of deployable or releasable? Maybe it's baked into your definition of done, maybe it's separate, but do you have it? Is it explicit? And the reason I ask these questions is, how can you improve what you don't fully understand? You can't. Many teams that are running Scrum, for some reason, really don't like process. They think Agile means you don't need process. And of course, that is completely not true. The people came up with the Agile concepts understood and embraced a lot of lean principles, okay? What they were against was not process. They were against heavyweight, useless, burdensome process. So process is not bad and it's not good. We judge process by the outcomes. If we're getting good results, our process is beneficial because it's helpful. If process is getting in our way of getting our work done, then it is not beneficial and we should get rid of it. It's wasteful, okay? As an example, you all know we're going through the coronavirus crisis now in this country. There was a device invented by Battelle in Ohio that could sterilize 80,000 surgical masks a day, and 95 masks a day, which would greatly ease the burden of lack of supply of these masks. But there was a regulation where it had to be partially approved, where even though it was tested and could do 80,000 masks, the initial regulation only allowed 10,000 masks a day to be cleared by the machine. What was the point of that? It was a very cautious, risk-adverse approach. We're going to let it run for 10,000 masks a day, and then that seems to work for several months. Then we'll let it go up to 40, then maybe to 80,000. In a crisis, you cannot afford to wait. And quite honestly, we can all see the risk averseness of that decision, but if the machine can do 80,000 and it's tested in the lab, what is the point of only limiting to 10,000 masks a day? There's an example of useless, wasteful process. And of course, the Corona Task Force was right to spot that and get rid of it. Again, given some prompting by the company and the state political leaders who said, this is ridiculous, okay? Be willing to challenge useful, wasteful process organization, but don't throw the baby out with the bathwater, okay? Process is useful if it's designed and used correctly, okay? But again, if you don't understand it, if it's not explicit where everybody agrees on what it is, you really don't have process, you have suggestions, and so you can't improve it if you don't fully understand it. You can't improve what you can't measure. This is more in line with what we're just talking about. Now, what do you need to measure? How about the rate of our ability to deliver backlog items over time? We call that velocity. Velocity is a rate figure. Now, do I have to estimate in terms of story points to determine velocity? No. I can start off by just doing that count velocity, the number of items that I can complete in a sprint. Now, if items are different sizes in terms of they have different magnitudes of work, then some sprints I'll get more items done, some sprints I'll get less items on. But the central limit theorem, the law of large numbers, tells us that over time, my average velocity will be good enough to predict what I can get done across several sprints on a per sprint average, okay? So measuring item velocity is not great, but it's a low maturity approach, but it certainly has more maturity than not measuring velocity, which has no maturity, okay? You can learn to quickly, efficiently, and consistently measure the magnitude of work of backlog items. Conventional wisdom and estimation in this industry is not just wrong, it's uninformed and harmful. There is the no estimates movement in the Agile world. Quite frankly, I don't understand it. Just because people don't know how to do something well does not mean that doing something well has no value, okay? So if you don't know something, learn how to do it. Not hard at all, okay? Metrics around defects are also important. How many defects do we find during the average sprint? How many defects do we fix during a sprint on average? Are those numbers going up? Are they going down? Why? Okay, remember that metrics never give you answers, they give you questions, right? Okay, our job as thinking people is to answer the questions, is to come up with an explanation that we can test to make sure we fully understand what's happening, okay? The rate of discovery of existing defects versus ejected defects is another important metric. What do I mean by that? Existing defects are defined as defects that existed before the current sprint, okay? Really before the current release. An injected defect was created during the current release cycle. Why is it important to know those two? If my rate of discovery of existing defects increases, it means my testing is getting better. What if my rate of discovery of injected defects increases? It means our developers are getting worse. So over time, we should expect to see the number of existing defects increase, the number of injected defects decrease, and then eventually the number of existing defects also decreases until we get to very close to 0 defects. Now, 0 defects, is that possible during software development? We'll talk about that in a few seconds, okay? Think about it though. Now, we also like to categorize defects by what kind of defect they are. Is this a requirements defect? Is the requirement wrong? Do we implement the requirement correctly, but it's not what the customer wants? Do we have a design defect? Does the product or functionality work as we would expect, but it's not performant? Okay. This might be the 20-second page refresh on your website that annoys everybody. You get a beautiful page when it's done, but who wants to wait for 20 seconds, right? That's a design defect. We didn't have sufficient design. And then there's implementation defects. The developer, to be quite honest, just blew it, just made a mistake, okay? Those are easy to fix, right? Why is it important to categorize our defects and know where they are? Well, again, if most of my defects are requirements related, it does no good to focus on improving my design or improving my developers' implementation skills, right? I'm not gonna, that's like looking for my car keys under the street lamp when I lost them back in the alley, okay? If you have a pie chart of all your defects, you just look for the biggest slice and focus on practices that will reduce that. Eventually, one of the other slices will be the biggest slice. And then focus on practices that reduce only that. You keep that process up, and pretty soon you still may have big slices, but the pie is very, very small. That's where we want to be. Okay, so again, metrics don't give you answers, they give you questions, but you have to ask those questions and find the answers. Okay, remember, if you can't measure it, you can't improve it. Don't let inertia constrain further improvements. This is not about fixing things once and being done. Don't let perfect be the enemy of better, okay? You don't have to be perfect to get better. Remember that a large part of this process in a complex environment is not knowing what to do. Trying something and that it doesn't work is valuable because you've learned something, okay? So if you're a leader in an organization that runs Scrum, ensure that your teams have permission to fail reasonably, to try something, and if it fails, to back it out and try something else. However, failing to learn is a mistake. Don't tolerate repeated failure to learn for the same reason, right? If people keep on hitting their heads on the wall and getting a bloody forehead, they're not learning. A little improvement goes a long way in our world. Most impediments share the same few root causes, right? The 80-20 rule, the Pareto principle, applies to a lot of things in life, including impediments, okay? Fix the root causes and things improve markedly. There's a lot of low-hanging fruit out there in organizations that if you just fix a few things, all of a sudden work seems to be happening a lot smoother, a lot more easily, a lot quicker, right? Remember that perfection is not a destination, it's a journey, right? And it involves continuous change, right? So the only failure here is failure to learn, okay? You have to change in order to learn. If you keep on doing the same thing, you're going to get the same results. And that's why I mentioned inertia. A lot of people will go through a short period of change and see a pretty significant improvement and then stop. I'm encouraging you not to stop, right? And let's look at the Kanban principles that talk about this. We want to start with where we are today. Start with what we're doing now, get agreement and consensus across the team that we're going to agree to pursue incremental evolutionary change based upon data, okay? Using the scientific method. We're going to figure out what a problem is. We're going to make one change a sprint, and that change should lead to an improvement. and we're going to repeat that forever. If you change just one thing a sprint and you're running 2-week sprints, that's 26 changes in a year. That's a lot of change. Don't try to change 10 things coming out of a sprint review, because if you try to change 10 things, you're like the developer who changed 10 lines of code trying to fix a defect, and you don't know which one worked and which one didn't. Remember, we have the controlled variable and we have the fixed variable. So we're going to change one thing, we're going to determine what the impact of that change was and whether it was what we wanted or not. If not, we back it out, we try something else. If so, great, let's try it. If it works, now we bake it into our processes and move on to change something else. So let's talk about that strategy for improvement, right? Initially, set a readily achievable goal in terms of the magnitude of work your team can get done in a sprint, and you can do with certainty, okay? And remember that less is more. It's better to undercommit and then deliver than to overcommit and not deliver, okay? During the sprint, focus on your goal to ensure the work is complete with quality by the end of the sprint. Once you can consistently set a goal, even if it's not very aggressive, and hit it, then we want to use the lean principle of lowering the water to exposing the rocks. Now, what this means is we want to gradually increase the goal in terms of magnitude of work. Okay, we want to bring more things with more work into our sprints gradually to figure out where the pain lies. Because if we can do 5 items and maybe they're all the same size pretty readily, let's try doing 6. Let's try doing 7. Let's try doing 8 over time. And by bringing that extra work in, it will show you where the real impediments are, because it reduces the time you have to handle them, okay? And then the solution is not to work more hours or to add more developers. The solution is to figure out better ways of doing your work so we can get more done in the same amount of time with the same stress with the same people. That's how we get better, okay? Think of it as push-ups. If I can only do 10 push-ups at a time, maybe I'll do a set of 10, and I'll wait a few minutes, I'll do another set of 10. And in a couple weeks, maybe I can do 12 push-ups. So now I'll do 2 sets of 12, or maybe I'll do 3 sets of 10, and pretty soon I can do 20 push-ups without stopping, and then 30, and then 40, and then 50, and then 100, okay? Rome wasn't built in a day, but it was built. Continuous, evolutionary, incremental change is the secret of success here. So let's talk about what we've learned and what we want to conclude, okay? Some key points here. Defects are accidental and avoidable. They're not essential and unavoidable. Now let me clarify this. As we do work, we're humans. Humans will make mistakes. Mistakes by software developers invariably result in defects, okay? That's fine, okay? We can't avoid creating a defect. We can avoid letting that defect live past the end of a sprint. We should be finding and fixing our defects within the same sprint, okay? By that criteria, again, if I have a backlog item that looks like it's done, but we have a known defect, it's not done. We don't call it done. It has to live and be resolved in the next sprint before it's done, right? So this is what the done criteria is used to prevent those defects from progressing through a workflow, okay? Deal with defects when and where they're created. Don't let them accumulate to the end of the development cycle. Defects are a form of uncertainty. Uncertainty decreases our ability to get work done. It decreases velocity. Think about it. If I let my defects accumulate over a 6-month release cycle, I'm in month 4, and I'm trying to add some functionality and it doesn't work. Is it because of something I'm doing today, or because I'm building on a lousy foundation based upon defects that were left in by another developer 2 months ago? Where if I keep up with my defects and I'm building on a solid foundation, if what I'm doing today doesn't work, then I know it's what I did today. And so the amount of code I have to look through is a lot smaller and a lot more defined. I reduce the uncertainty of the problem, and that will increase velocity, okay? If I see similar types of defects or other impediments on a continuing basis, repeated issues that are similar often point out a root cause that is shared across those issues, right? And we can fix that with a rules change. So there are 2 types of issues that we come up with organizations. Deming called these things variance. Variance means a change or a different outcome than what we would expect. There's what we call external variance, which is variance caused by an external factor, and there's internal variance, okay? Short refer to those things as common cause variance and special cause variance. So special cause variance is equivalent to external variance. We know when we have external variance because we can all point to it. Let's say we didn't hit our sprint goal this last week because we had a major power outage and we lost power for 3 days at our business and we didn't have the equipment we needed. So therefore, our developers couldn't work. And therefore we didn't hit our sprint goal. We can all point to the weather or whatever caused a power outage as external variance. Now we don't want to make a rules change, but we can mitigate the impact of such events. Perhaps we install a backup generator. Perhaps we buy all the developers laptops with batteries so this would never affect them. Perhaps we install UPSs at our network points within our building and get our servers up and running on them so they can bridge the gap between the power outage and the generator kicking on, so we never have to worry about not having power again. So we can mitigate external variance by providing provisions to handle the risk. Okay, with internal variance, or what we call common cause variance, she would also call this random variance or chance, because it looks like all different kinds of things cause this, right? Like defects. We have a lot of defects, but it seems like they have different causes. But do they really? The undesirable effects will probably be manifestly different, but most of the time they have a common cause root cause. They have the same root cause. And this is where a rules change comes in. For instance, if we find that we are continually having problems getting backlog items done because maybe our UI is not right here, our functionality is right there, the root cause is really a lack of an effective refinement process. So that rules change can fix a whole slew of these types of errors. That's why it's important to look for relationships and patterns when we consider the changes we want to make to process, right? We talked earlier about defects being a form of uncertainty and how uncertainty decreases velocity. If you want to increase your ability to get work done over time, focus on quality. If you do that, you're going to go faster without hiring more people, without spending more money. You know, there's the old saying that says, if you don't have time to do it right, when are you going to have the time to do it again? Remember how I talked earlier about rework and the percentage that rework takes in a lot of our teams? If your team is spending, 2 or 3 days a sprint fixing defects across a team, that's 25% of your bandwidth. If you could cut that in half, that would give you better than a 10% productivity gain at no cost. And you should be able to at least cut it in half with appropriate rules changes, process changes based upon analysis of common cause variance. We want to define a standard. We want to be able to measure our performance to that standard. And then we want to change our processes and practices to meet and then exceed that standard. T.H.O. Ono, who was one of the inventors of the general production system, had a great saying: without a standard, there could be no improvement. Because if you can't measure yourself against it, you don't know if you're doing well or if you're doing badly. And then if you make a change, you don't know if the change was positive or negative. You have to have a standard to measure against. The difference between engineering and artisanship or craftsmanship is the difference between having and not having defined standards and processes. It's why we can all buy beautiful furniture from Ethan Allen today at very affordable cost compared to buying antiques made 150, 200 years ago that only the very wealthy could afford. Okay? Quality is impossible if everybody makes up their own mind about what it means. Okay? You have to have a standard definition of quality. So I've mentioned the term high quality a few times. Let me give you a quick definition of high quality. High quality has three criteria. You must satisfy the customer. Okay? You must conform to all functional requirements. The product must do what it's supposed to do. And you must also comply with all non-functional requirements. The product must do what it's supposed to do in a way that is performant and robust and reliable. Okay? This applies to any kind of product, not just software, right? If I go to the local McDonald's and order a Big Mac and they give me a fillet of fish, they certainly haven't satisfied the customer. And that product also does not comply with the functional requirements of a Big Mac. It doesn't have special sauce on it. It's a fillet of fish. It doesn't have 2 all-beef patties. It has a piece of cod. Okay, so they did not meet the functional requirements and they did not make the customer happy. What if I do get a Big Mac, but I eat it and I get food poisoning? Well, the non-functional requirements, these are the things we have to specify because we don't live in a perfect world, how well the product does what it does, imply that I should never have to worry about food poisoning when I go to a restaurant. And I think you would all agree on that, right? Okay, so a Big Mac that looks like a Big Mac, smells, maybe tastes like it, but it gives me food poisoning, did not meet the functional requirements of what I expected. So therefore, it was not a high quality product. Okay, this applies to software. It applies to Big Macs. It applies to soft drinks, smartphones, you name it, it applies to it, right? It applies to airline travel, anything. Okay, so use that definition of high quality, figure out how it applies to your product or service that you're creating for your customers, and then measure your performance against it. Okay, so you have to have that objective definition for what it means to improve, and you have to have a way of measuring it. Otherwise, no improvement is possible. Now, here's something I want to remind people. You can measure anything quickly and accurately enough to make decisions, but you don't have to measure everything perfectly to measure well enough to derive a benefit. So I have a saying: do I have to drink a whole glass of milk to know it's sour? No. 1 sip, maybe 2, is all I need, right? Then I can make a decision. We measure for the purpose of making a decision. Once I have enough information to make the decision, it's good enough. Make the decision and drive on. Finally, let's talk about rationality when it comes to teams, right? Doing the same thing while expecting a different outcome is the definition of insanity, right? We call this the insanity loop. People do something, they don't get the results they want, so what do they do next time? They do exactly the same thing, right? You cannot improve if you do not change the way you work. And you cannot improve if you cannot measure your current level of performance given the current way you work, right? The challenge that we see with most organizations is overcoming cognitive biases, right? People know how software should be developed. They know how Scrum should work. They know how they should estimate. And I always have to remind people that it's not what you don't know that keeps you back. It's those things that you absolutely know that are just incorrect, okay? So be willing to consider the possibility that what you believe is the correct way to do something may not be correct. Challenge yourself, okay? They say that a sign of intelligence is to be able to have two conflicting ideas in your mind at the same time. Think about that when you look at process. Just because it's just how you've always done it doesn't mean it's the best way to do it. Okay? The results will tell you whether it works or not and how well it works. I want to remind people that most of what comprises the conventional wisdom about Agile and Scrum that you find on the internet is not just wrong, it's actually deleterious to improving your agility, your ability to respond effectively, right? So if I read the internet, it tells you that there is no room for managers in Agile. Scrum does not have a manager role. You're right, Scrum does not have a manager role. Organizations have a manager role. And a Scrum team that ignores the role of a manager probably won't be running Scrum for very long, right? Think about that. Would you hire a contractor to come into your house who's going to do what they want and not what you want? Who's not going to tell you when they're going to be done with the work that you want done? Who is not going to tell you how long it's going to take so you can derive how much it's going to cost? No. You think your organization is any different, right? Okay, self-managing does not mean self-directing. Okay, the organization sets the goals. Self-managing teams means that Scrum teams get together and collaborate to figure out how best to accomplish those goals. Sure, we want feedback and input on our Scrum teams on the goals we set, but eventually somebody, a stakeholder, makes a decision. And then we have to agree with it, we have to buy into it, and we have to try to make it happen. Because here's the thing about execution. If you don't believe in something and therefore you don't push to make it happen, then of course it's going to fail, okay? There's often many ways to solve a problem, to build a product, to provide a solution to the market, some of which are equally valid. There is no one correct way, okay? So if we're going to increase our performance and increase our agility, our ability to respond effectively, we have to use engineering principles. We can't rely on heroes. We can't reject discipline or thinking rather than guessing. Okay, so here's my call to action for everybody. You've been through this seminar. We're going to have a Q&A session in a second, but during that Q&A session and afterwards, I think it'd be very helpful for you to think about what you're going to do differently. What will change in your organization by the end of the current sprint? What would you do differently? What would you encourage your team to do differently or your organization to do differently? And similarly, look at that time frame by the end of the next sprint. Are you going to try something different? What about by the end of the quarter or by the end of the year? And we'll talk about it a little bit during our Q&A session. We'll throw some things out there. So this is where we want to have a little bit of a Q&A session. I know that our moderators have been gathering questions, and we'll look and we'll see what we have. And give me a few seconds because I may have to do some manipulation of where I am to go ahead and look at the question queue. And I will see what questions you guys have. Any questions, anybody?
There are two in the new queue there, John, if you see it, or I'll read them to you.
Yeah, could you read them to me?
Sure. Anonymous asks, what if you run into a block that's going to take several sprints to solve because it's a much bigger issue than initially understood? Unfortunately, this must be solved before any additional work can be completed. Do you now keep doing sprints that are set up to solve the problem until it's solved?
That's a good question. So I always remind people of a variation of Hoare's law. That's Charles Hoare, who was a software thought leader back in the earliest computer industry. And he had a saying, inside every large program is a series of smaller programs trying to get out. And I rephrase that. Inside every large problem, there's a series of small problems that are struggling to get out. In short, the way we solve problems is to do a divide and conquer approach. We take a large problem, We divide it into a series of smaller problems or challenges, and then we solve each one. So even if I have this large, hairy problem that's going to take several sprints, the first step of solving a problem is defining it and decomposing it into smaller, discrete problems that we can solve within the confines of a sprint. So I may create new backlog items that are about addressing this problem, and then I can still run sprints, but I'm going to run sprints working on that problem.
All right.
So the question?
Yeah, there's a second one here.
Okay.
Michelle asks, I'm working with a set of managers who worry that if you don't give the team stretch goals every sprint to make sure the team is 110% busy and productive, we're not pushing the individual contributors hard enough. But then teams often miss their sprint commitments. I'm trying to convince that it's better to have stable velocity and a high percentage of met commitments, plus a prioritized backlog for times when the ICs run out of work in the sprint and they need to pull a new ready task. What other advice do you have for changing this management mindset?
That's another great question, and we run into this quite often. What I see, well, let me step back and say, if I could find the guy who wrote that original article about stretch goals and shooting for the stars and you get the moon, and I think it was in a Harvard Business Review article maybe a decade or two ago, I'd like to punch him, just because that has done a lot of damage to a lot of teams. I believe in stretch goals, but I believe in stretch goals that people or teams set for themselves. I don't believe in imposing stretch goals on a team. And here's why. Because if you believe you can or believe you can't, you're probably going to be right. Everybody's seen a cute little dog that maybe a friend or a neighbor has, or maybe that you have. And of course, we like to hold up a little treat, make that little dog sit up and take the treat. And of course, if you have a kid doing this, the kid will make that thing higher and higher. And of course, the dog will start to jump to get the treat. But eventually, even that little walnut brain of the dog's head realizes it just isn't going to happen. So when you have a goal that is so audacious that the team doesn't believe it can hit it, you don't motivate people to get more than they would ordinarily do. You demotivate them and you'll get less than you'll probably get done. So if I believe I can do something that's difficult but achievable, I will exert myself to accomplish that goal. But if you set for me a goal that I know I can't do, why would I kill myself trying? For instance, if you run and you can run a mile in 7 minutes, maybe I can run a mile in 6.5 minutes if I really push myself, but I'm not going to run a mile in 5, and I'm not even going to try. Mm-hmm. So let teams set their own goals, encourage them to be aggressive, but to set reasonable aggressive goals. So I think a team should be stretching, and if a team doesn't make its goals, but their velocity, their amount of work they get done per sprint is increasing, that's a good thing. So, but if you can't be repeatable, you can't improve it. This is what we talked about. You have to be able to measure to improve it. So the first step to improvement is getting to repeatable, be able to do the same amount of work repeatedly, because repeatability implies predictability. It implies a defined process that's well understood by the team. And then we can start to stretch it to see how well we can do. Okay, but when external managers think they're going to trick the team into getting more done by setting a higher goal than they know the team can do, what they're really telling the team is, I don't trust you not to work hard unless I'm behind you with a whip beating you over the head. And that's not a good message to send.
Mm-hmm. Do you think there's any value in some of Don Reinertsen's writings around the difference between utilization and throughput?
Of course, and we talk about this quite often in our classes. So I'm looking out of my office window right now at the local interstate 405 that runs right through downtown Bellevue. And of course, we're in the era of the virus, but usually at 5 o'clock on a weekday, I can look at that, 5 lanes on each side, and I can look at the number of cars. And you can imagine that on any busy freeway or interstate or highway that goes through a major metropolitan area during rush hour, the amount of utilization of that resource is 100%. Okay, the cars are nose to tail packed in there like a parking lot, and there's no throughput. They're not moving past a fixed point. Okay, so we know from queuing theory, and Reinertsen talks about this, that about 2/3 of queue utilization gives us the maximum throughput, and there's a reason for that. It gives us enough slack to account for variance in arrival and departure rates of items to and from a queue. So when we start having more work in progress than we have slack to account for variance, we start getting what we would call in traffic a traffic wave, start and stop cycles. And eventually, if you have too much utilization, things come to a screeching halt. So utilization is how busy people are. Productivity is how much is getting done. Do we care about utilization or do we care about productivity? Now we often
I think sometimes management fails to be able to measure productivity and has this sort of false god of utilization instead because they can measure that.
Yeah, so we often measure what is easy, not what is valuable. Agreed? And so what we have to do is stop measuring what is easy and start measuring what is valuable. So there's a great book out there by a guy named Douglas Hubbard. It's called How to Measure Anything. And I believe that anything that's worth being measured can be measured to a level sufficiently to help us make better decisions. And that includes productivity. So in the Scrum world, velocity, the amount of items that we can get done per sprint, is a productivity issue, right? Because if we're more productive, we should have a higher velocity. Okay? But this requires us to have a valid estimation approach that doesn't look at duration, it looks at the magnitude of work. Because again, my duration depends upon the person doing the work. If I have a junior developer who's just out of college, he will have a hard time getting some work done on our code base when he doesn't know the code, may not know the technology. Whereas a senior developer could do it very quickly. So the duration of that work depends upon the person who does it, but the amount of work that actually done is identical for both people.
Yeah.
The problem with the inexperienced guy is a lot of his bandwidth is occupied in learning and not actually doing.
Okay, Michelle has replied with 3 thumbs up, so I think we answered that question pretty well for her. I'm glad we could help Michelle. And that is the bottom of the list, so I think we're done.
Well, I thank everybody for attending. I hope you enjoyed it. Please be willing to look at our website to find more topics we've done. So this will be recorded and be made available on our website. We also have the sessions from previous Lunch and Learns, and we're going to continue this process at least until the end of April. And we encourage your input and feedback. And you can ask us questions or contact us if you have more questions that you would like to talk to, or just schedule a talk with us. We'd be glad to talk to you about these subjects and give you some high-level pointers and see if we can help you, because that's our business. We're here, again, to help you be more successful by helping you understand better effective software development and management practices.